Hello students. This session is all about learning an important concept in mathematics, something that forms an integral part of the subject, and it is called trigonometry. But before we start exploring it, let's try and understand this picture over here. So sun rays reach the top of the tree at some instant and a shadow is being cast on the ground. And at the same instant, another ray of sunlight reaches the top of a stick placed nearby and its shadow is also cast on the ground. Now suppose I find the height of the tree and compare it with the length of the shadow. I can get a single ratio from these two quantities. Then I can write another ratio for the stick as well. So we have two ratios now. What do you think? Would these two ratios be the same or would they be different? To answer this question, let's form two right-angled triangles as shown here. So we will name the bigger triangle as triangle ABC and the smaller one as triangle PQR. And at any given time, the rays from the sun are parallel to each other. So BA and QP lie on two parallel rays. Now using this information, we can say that angles A and P are the same. And also, we know that angles C and R are the same as they both are 90 degrees. So, by the angle or AA postulate, the two triangles are similar. And because they are similar, the ratio between their sides, that is BC by AC, and the sides QR by PR is the same. And this property is of similar triangles that you've already seen before. Also, these ratios depend only on the acute angle A or P. The ratios change if the measure of the acute angle changes. But they do not depend on the size of the right-angled triangles. So, we now have the answer to the question we started with. Yes, the ratios of the tree's length to the shadow's length is exactly equal to the ratio of the stick's length to the shadow's length. Now, why did we take in particular the ratios of the sides of a right-angled triangle? Well, these ratios are so important in mathematics, physics and engineering that there is a whole branch of mathematics based on them. Trigonometry. So the word trigonometry is derived from the two Greek words, trigon meaning a triangle and metry meaning measurement. So trigonometry refers to the measurement of triangles. Trigonometry has been studied since ancient times. Even before modern science developed, astronomers and builders used trigonometry in their work. Now to begin learning about trigonometry, we will focus on a right-angled triangle again. As you might have guessed, we are interested in the ratios of side lengths, for example, AB by AC. So how many different ratios can you write using these three side lengths? 6 different possible ratios among the sides of this triangle, and they are listed here. So basic trigonometry is about these 6 ratios, their properties and their applications. Not surprisingly, we call these ratios as trigonometric ratios. So I hope you are clear with all these things. Now let's do a quick recap. So we've learned that when there is one common angle in two right-angled triangles, the two triangles are similar. We've also learned that in similar right-angled triangles, the ratios between the corresponding sides of the triangle are the same. And these ratios depend only on the acute angle of the triangles. We also saw that there are 6 possible ratios between the sides in the triangle. And at last, we call these 6 ratios in a right-angled triangle as the trigonometric ratios, since they play a very important role in trigonometry. So that's all for now. I'll see you in the next session.